Hello, welcome to my stream. If you're new here, I'm Jared. I'm a Ruby programmer, been doing it for far too long. I run a consultancy called Super Good Software where we build Ruby on Rails e-commerce systems. We specialize in a platform called Solidus. Tonight, as with every night where I'm free, until the 25th of December, we are solving Advent of Code puzzles. They are programming puzzles, Christmas themed ones, that they're just fun. They're just fun puzzles. Last night, what were we doing? We were mapping the hydrothermal vents on the seafloor, if I remember correctly. Ran into a couple of stumbling blocks in terms of our just our thinking, or my thinking. Wasn't much contribution from chat last night, but ran into a few hiccups. So hopefully aiming for a little of a smoother one tonight. So let's just hop over to puzzle here and get to it. Day 6, Lanternfish. The seafloor is getting steeper. Maybe the sleigh keys got carried this way. A massive school of glowing lanternfish swims past. They must spawn quickly to reach such large numbers, maybe exponentially quickly. You should model their growth rate to be sure. Although you know nothing about the specific species of lanternfish, you can make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. We're very observant and can extrapolate from limited information. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. Furthermore, you reason a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. 2 more days for its first cycle. So suppose you have a lanternfish with an internal timer value of 3. After 1 day, its internal timer would be 2, so on and so forth. After another day, 6 would create a lanternfish with interval, blah, blah, blah. Yeah, so we'll walk, reasonable example. A lanternfish that creates a new fish resets its timer to 6, not 7. Because 0 is included as a valid timer value, sure. A new lanternfish starts with an internal timer of 8 and does not start counting down until the next day. Realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfish, your puzzle input. For example, suppose you were given the following list, 34312. That means that the first fish has an internal timer of 3, the second fish has an internal, etc., etc. Yeah, we understand. So here's an example. Sure. Each day 0 becomes a 6 and adds a new 8 to the end of the list, while each other number decreases by 1 if it was present at the start of the day. In this example, after 18 days, there are a total of 26 fish. After 80 days, there would be 5,934. Find a way to simulate lanternfish. How many lanternfish would there be after 80 days? Yeah, okay, so things looking good over there. So get into it. This is day 6. Oh, I keep forgetting to, doesn't matter. Day 6, sorry, my fuzzy matcher configured differently on my regular user. So we're expecting a value of, and before I run into the issue that I ran into yesterday, day 6, part 2. Just going to do that. And so this is our initial state. We can go look at the puzzle input, but it's just what we expect it to be. I have a thing that automatically downloads it, so we don't have to worry about that. We don't need the here doc here either. I mean, the first thing I want to do is turn that into an array of numbers. After that, I'm gonna want to do, I mean, I'm just gonna iterate just like 80 times, do something. All right, so we've got our input. We can say, I'm gonna do what I often do. So we are going to say state equals state.new input, split that on the commas, and map it to numbers. That'll give us an array of numbers, and we're going to create a state here, struct new fish. I don't know, and it's gonna need some methods. So I often like to model these as like immutable operations. So I create like a objects that return new dated objects. So for example, we're gonna do we're gonna do 80 times, that's 90, 80 times state equals state.next, and then we're going to return state.fish.length, or we can even just give this a count method, and it's just going to be fish. Okay, seems fine, seems fine. Ooh, got a good pop out of my neck there. Now we got to implement next. That seems like the hard part. I mean, I guess we can run this, make sure we get the failure we expect. The failure we expect to see, which is undefined variable method fish. That's because that was supposed to be a symbol. Find method next for nil class. So this returns self. That would work, but wouldn't produce the right result. Can I do class new? We want to initialize this with the current fish mapped through something. Uh-oh, fishes. Fishes, we're doing fishes. Pluralizing fishes. So that I can have a singular and a plural that are different words. I'm just gonna hold off on that for a sec. So let's review our logic here. If fish is 0, then we need to do something, else we do a different thing. The different thing is fish minus 1, and here this is 6. So fishes are 0, we reset them to 6. And then we need to add, I'm just going to bind it up Ryan here. debugger time, just test what we want to do here. So that, oh, right. It has to be self.class.new because Ruby syntax. So if we have a number like 13, how do we make, can we like, yeah, that's what I want to do. So the first one is the count, the second one is the value, okay? I'll just let that run out. So we'll do the map and then we'll add on array new, new fishes, and they start at 8, right? Oh, left my pry in there. We got 5, so that's a suspect. Right, because we're never adding new fishes. So we say new fishes plus equals 1. Remove our pry here. And that seems to work, so let's see if it works with the real puzzle input. Wasn't fast. There's a noticeable delay there. Probably worked. Yeah, all right, so that works. Git add, git day 6, part 1. All right, on to part 2. Suppose the lanternfish live forever and have unlimited food and space. Would they take over the entire ocean? How many lanternfish would there be after 256 days? Huh. So here we go. Let's go get day 6, part 2. Oops, I wanted day 6, part 2 spec. Let's open day 6, part 2 here. Remove this, so I suspect when we parameterize this thing, this one, iterations is going to be 80, and I suspect when we make the iterations 256, same input here, this is going to not perform well enough, and we're going to have to do some optimization. An array that would be that long would be too long. There we go. Okay. Confirmed. Too long. So the optimization we can do here, I think, is actually probably pretty simple. Instead of modeling this as an array of numbers, we'll just model it as a hash where the keys are the number of fishes with are the timer counts, and the values are the number of fishes that have those timer counts. And then we don't have to iterate over this massive array. We just end up with some big numbers for the values, but we still never end up with we still only end up with like 9 keys, 0 to 8, and just really big numbers for the values. So we're not iterating over this massive array every time. Given that, I think we can just optimize our day 1 solution rather than doing anything with our day 2 solution. So we're going to use, I'm pretty sure there is a method called tally here that we can use. It's going to become fishes dot values dot length. I'm going to try in here though. So fishes, did tally do the right thing? Yeah, it did. So this is saying we had 3 fishes, or so we had 2 fishes that had a timer of 3, and 1 fish that had a timer of 4, and 1 fish that had a timer of 1, and 1 fish that had a timer of 2. Okay, I think we can just, we're gonna have to exit here. I think we can just think really hard and do this, right? So scrap this, probably. I don't know, let's just push it out of the way for a sec. Don't think we need a new fishes variable. So fish is gonna be old one. So the new state, new fishes, I won't call it new fishes. That's confusing, but we're not here to write production code. So if I'm going to transform this I'm going to transform our hash into an array. So it'll be like key value pairs, and then transform it back into a hash. Ruby has like a transform keys and a transform values, but I don't know that it has like a transform keys and values. So I think we'll not worry about that. So if there's kind of just mapping here, so the values, we're not changing the values. It's just we want to change the keys that they're at initially, right? I think that makes sense. So we'll say here, we'll say key equals 0. Then we want 6. Otherwise, we want key minus 1. So that moves all of our count of fishes that we say at timer 5 to timer 4, or from timer 0 to timer 6. And then new fishes, ones that are at timer 8, is just going to be the number of fishes currently at timer 0, like in the previous state. Is that right? Did I do that right? No. Definer minus for nil class. Cool. Oh, I'm not turning this thing back into a hash. Cool. Expected big numbers got not big numbers. What am I doing wrong here? Made sense in my head. How do I debug this? I'm just gonna start poking around. So we're in here, fishes, we got 3, etc., etc. Our key is 3, our value is that. Yeah. And just sort of test that we're gonna get the right value. Yeah, we expect the key to be 2, the value's gonna be the same, cool. mean, we're not, it sounds like we're not getting any fishes added, so let's, where did I fry here? Not that fry, not that fry. This one. So new fishes. What does this look like? Fishes. Oh, there we go. There's a problem. We have no zero fishes here. I don't know how we're not getting an error. Give it a default value. Still not working. Okay, okay. Let's go through some iterations, see what happens here. We still need to pry in here though. All right, new fishes. That seems potentially right. Oh my god, I did the thing that I keep doing. No. Values, I didn't sum them. I took the number of values that were in the hash, not the sum of the values that are in the hash. Oops, try. Well, that's interesting. Six. Could we possibly be getting 6? This is very silly. I'm obviously missing something. Oh, I'm overwriting. Haha, that's clever. Okay, so I'm overwriting the fishes as they approach 6. So there's 2 ways to try here. If we pry right there, I can confirm the mistake that I've made. So new fishes here. So now we have a fish at 6, and so we have 1 0 fish and no fishes at 7, which is not useful for illustrating this. Still have 1 0 fish, no fishes at 7. So now we have, still not useful. How am I never ending up with fishes at 6? What am I missing here? What is going on here? Nothing is changing ever. Fishes is what it's been almost the entire time. 4 1 1 1 0. Whoa, what am I doing wrong here? Oh, new fishes equals. Oh, I see. I've introduced a new bug when I went to try and debug this. Huh. This is supposed to be new fishes. All right, now let's see if we can see my bug. So, new fishes is what I want to look at. So there's currently one fish that should head into the 6 spot and 7 fishes. Sorry, zero fishes. No, that doesn't help. Here we go. This is the issue. Got a hash key collision here. If I could think of a bunch of ways to do this. I could just construct this hash though. It's just not that hard. Alright. We could just save ourselves. This seems like too much work. We need our ones. All up to 8. It's just really hard to type numbers. Okay. 0 is going to be fishes fetch 1 or 0. This is almost just the handle our special case. So we're gonna have the number of 8s equal to the number of 0s. In the previous one, the number of 0s equal to the number of 1s, the number of 1s equal to the number 2, number 3, 4, 5, 6. This is a special case, and 8. So this is fetch the number of 7s plus the number of 0s. Right? I think that's right. Not pretty, but cool. Works. Solve part 2. Works in a relatively short amount of time. I'm going to say our basic thinking was good. It was just that we ran into some issues with my implementation. So cool. All right. Well, thanks everyone for coming out. I'll also be posting this one on my YouTube and that kind of thing. As far as I know, I'm free tomorrow night, so I should be back here for day 7. Thanks, everyone.